Okay, here's the solution video for Miniquiz 6.2. Now, for convenience sake, I've already written down the names of all of these parent functions and relations. This mini quiz was more of a memorizey one, which I don't like them either. That's why I went into math, but some things you just have to memorize. And at least the names of these is something you should memorize. So here you can see the different names. We've got our linear function, our quadratic, our constant, our cubic, our square root, our vertical line, a reciprocal function, a reciprocal square function, and an ellipse. And meanwhile, the other two that we studied but aren't on this mini quiz were our circle and our cube root functions, both of which are still available to you during our function art project. Okay, our first question asks us, which of these equations go to these which graphs? Y equals 1 over x squared, easiest thing to do, just put it into your calculator. Just put this in your calculator. You'll see that it looks kind of like that, and that's why this has the equation y equals 1 over x squared. Similarly, the cubic function has this equation, y equals x cubed. Plug that into your calculator, and you should be able to get that this is y equals x cubed. Meanwhile, the form of the equation x equals just a number, well, that's not a function, is it? More on that later, but this is the form of an equation for a vertical line, which is right here. And as you can see, all of the points along that line have their x coordinate equal to -1. The second question asks which of these graphs correspond to these names? And well, if you've memorized the names at least, this should be a piece of cake. The reason that certain of these graphs have these names is because of their equation. For example, the reciprocal function is just y equals the reciprocal of x. Reciprocal square is just called because it's the square of x is reciprocal. An ellipse is the name of this shape. So these aren't too hard to remember, but it's pretty obvious if you once you do that the reciprocal square is h, the constant was c, our linear was up here, up on the upper right, sorry, upper left, that was a. Our quadratic, we studied those for 2 whole units. I think it's obvious that letter b is our quadratic function. And finally, our square root function is letter E, which has this equation, by the way. The next question asks us which graphs have domain -infinity less than x less than infinity. Another word for this phrase is just everything. This is all real numbers. So which of these graphs have domain everything? Remember that our domain is all of the x values. So assuming that this graph continues on, this is one of our graphs with domain everything, A. B, being y equals x squared, also has domain everything. We'll write an R there. The constant function does have a domain of everything, which we'll write an R. And so does the cubic. You can take any number and cube it. That is why it has the domain everything. The square root function clearly does not have domain everything. It doesn't include the negative numbers. Doesn't include those. So we're not going to put an R there. We won't put 1 for the vertical line. Clearly, it doesn't really have any of the numbers in its x. In fact, the only x value for this graph is that one there, -1. That's not going to need an R. The reciprocal function looks like it has everything as its domain, but looking closer, the number 0 doesn't work. If I tried plugging a 0 in for x, I would break math. Let's not break math. This does not have domain everything. Let's not put an R there. Similarly, for graph H, we can't put in a 0 for x. So the domain of this graph is not everything. Let's not put an R there. And finally, the ellipse, well, it might look like it kind of covers all of the x values visible, but if these axes continued, you'd see it only really covers the x's from -2 to +2. It doesn't go out forever. That doesn't need an R either. Which graphs have range that is not everything? This time it's everything on the y direction, everything. So A has a range of everything. So let's not put a y there because that's what the question says. The question says put a y next to the graphs whose range is not everything. B has a range not everything because it doesn't cover the y's below zero. This graph needs a y next to it. And so does this one, letter C, because it doesn't cover, well, almost any of the y's. Letter D covers all of the y's, so let's leave it alone for now. Letter E does not cover all of the y's. Let's put a y there. Letter F does cover all of the y values. See, that red goes up and down forever. It has all of the y's. Its range is everything. The reciprocal function, that tricky one again, it might look like its range is everything in the y direction, but again, it never touches that zero. And this makes sense. Look at the equation. Can you imagine what would happen if y equaled zero? We would get 0 equals 1 divided by x. Then if I multiplied x by both sides, I would get 0 equals 1. Does that work? No, of course not. That's why y can't be 0. Y does not have range everything. So let's put a letter y there. Similarly, the reciprocal square function, I mean, you can see it doesn't have everything as its range. Let's put a y there. And finally, the ellipse, it does not have range everything. It doesn't go on forever in the both up and down directions. The next question says, write the letter S next to the graphs for which as x goes towards negative infinity, y goes towards 0. Okay, so as x goes off towards the left of the graph, as we move, for example, in this direction over that way, or as we said in the last solution video, there's only three options. Either y can go up to infinity, down to a negative infinity, or it can flatten out to a number. Which of these graphs flattens out to 0? Linear doesn't, A doesn't, neither does B. C does flatten out, but not at 0. Not at 0. So we're not going to write an S next to the C either. D doesn't flatten out. E doesn't flatten out as it goes to the left. In fact, for E, it doesn't even go to the left. Neither does S. Letter F does not flatten out as X goes to the left. It doesn't even go to the left. However, the graph of G does. As this graph continues off onto the left forever, it does actually flatten out towards 0. Here we'll put a letter S. Similarly, the reciprocal square graph also approaches 0 as we move off to the left. And finally, the ellipse doesn't even go to the left. So we're not going to put an S there. Finally, let's write a letter F next to the graphs of functions. Remember that a relation is not a function, like for example, this one. This is not a function because there are some points that have multiple outputs for a single input. That is not what a function does. A function only ever has one output to one input. So if you can draw a straight vertical line and hit the graph twice or more, it's not a function. Okay, so we need to draw an F next to all of the ones that don't do this. They can't do that. Does the linear graph ever do that? No, it never does. No matter how I draw a vertical line, I never hit the graph more than once. This is a function. I'll put an F there. The quadratic function is a function. I'm never going to hit the graph more than once by crossing it with a vertical line. That's got an F next to it. Similarly, so does the constant function. The cubic function also only outputs one output for every input. Same with the square root. It's a function. The vertical line itself, though, is not a function. This is the only input, and it's got billions, in fact, infinitely many outputs. This is not a function. Let's not put an F there. The reciprocal function, though, does only put out one output for every input. So let's put an F here. Similarly, our reciprocal square should have an F because it only puts out one output for every input. All of these vertical lines only ever hit the graph once. The same cannot be said of our ellipse. If I draw a vertical line through almost any part of the ellipse, I will hit it more than once. I do not get only one output for every input, and so I will not draw a function f there. And so that is the solution for Miniquiz 6.2. There were many ways to make an error here. In fact, there were 44 different ways to make a mistake. You could have put an S where it didn't belong, or forgotten to put an S where it did belong. So if you count all of these possibilities up, graded out of 44 technically. So I just counted up your mistakes and subtracted that from 44, and that's how I got your grade.